Exactly. So, no hockey today, right? I mean, it's over. We've got our jerseys, they work. So here's a constant function, y equals 3. What is the derivative of this function? Now, what am I asking? What is the slope of the line, which is? Prove it. Glad you asked. Okay, so the constant rule, right? The simplest function is just a constant function, right? Y equals 3. And so the constant rule says, what's it going to say? So, constant rule. Or, well, here's what we're doing today, and now I'll just erase this stuff. The constant rule. Oh, are we not? No, we're doing the other stuff, but now that you've seen it, that's just where we're going. This is where we are right now. Simplest function. Is of the form y equals c, right? Where c is a constant which has a slope of 0, as we have seen, which zero. Which means, well, let's throw another comma in there. So I'll capitalize the S. F prime of x is equal, let's call it y prime, I called it y, so y prime is 0. And let's do a proof of that, only now we'll use f prime. And so we go to first principles, right? So what's the derivative? It's the limit as h approaches 0 of f of x plus h minus f of x over h, which is the limit as h approaches 0 of, now what's f of x plus h? Well, what's f of x anywhere? It's just c. And what's f of x? Also just c, which is equal to limit as h approaches 0 of 0, which is 0. Oval 0 there. Squeeze in on the side there. So that's the proof of the constant rule, right? If you have a constant function, the slope is 0, because the values are just always c minus c, which is 0. Well, that's exciting, but let's do, you've done some derivatives, you've done, let's do, all right, let's go to the power rule. And we've seen some of those derivatives, I think, but let's do, so the power rule says if we have a function of the form f of x equals x to the power of n. Okay, we want to come up with a rule. What's the derivative? I don't know if you've done some exercises where you've done some of these already. Maybe not. But let's do one for n equals 4. Okay, so let's try this with n equals 4. And see what happens. All right, so we're going to do okay, so our function is x to the n. We're using n equals 4. So it's going to be x plus h to the 4th minus x to the 4th over h. one. I never verified this. You all have done the binomial theorem, right? 30-1. Okay, so you know how to. I mean, when we square, we just kind of FOIL it out, or x squared plus. But we have a binomial theorem for doing larger expansions. Okay, so you know how that works, right? It's like 4 choose 0, x to the 4th, which is 1, right? 4 choose 0 is 1. So it's x to the 4th plus 4 choose 1, which is 4, x to the 3rd. Clean that up. X cubed h plus 4 choose 2, which is 4 times 2 over 2, which is 6. X squared h squared plus 4 choose 3, which is 4. So the powers of x diminish, right? They're going to go 4, 3, 2, 1, 0. And the powers of h increase. H to the 0, h to the 1, h to the 2. Okay, you remember this. If not, you can look it up. It's in your notes somewhere. Xh cubed plus 4 choose 4, which is 1, and then h to the 4th. Okay, that's like x squared, right? You get like x squared plus 2xh plus h squared. You know, but we don't use the binomial theorem for squaring because we. And then minus x to the 4th, that's this guy, all over h. Now you get this interesting pattern emerging, right? Which is, hey, an x to the 4th, but I'm subtracting an x to the 4th. And then all of these remaining terms have an h in them. So I can divide everything by h, okay? And if I do that, just extend this and scroll this back up. I divide everything by h, so it's still a limit. As h approaches 0, I'm going to divide everything by h, so here we're going to get 4x cubed plus 6xh plus 4xh squared plus h cubed. Right? So h divides out. And now, so what's going to happen to all the terms with an h as h goes to 0?
It's on 0.
They're going to go to 0. So what are we left with?
4x.
We're just left with 4x cubed, right? So we can say, d by dx, I'm going to throw in notation here, right, of x to the 4th is equal to 4x cubed. Is there a pattern there or something? Yeah. What do you think the derivative of x cubed is? Yeah. d by dx of x cubed. What do you think the derivative of x squared is? 2x. What do you think the derivative? Okay, well, I'll just give you a chance. Before we state the actual power rule. And then we're going to actually prove the power, because you asked for proof. I have proof. And then, so the only reason I did the x to the 4th was just to get you thinking binomial theorem again, so we could use it in our proof. Which I think is also in your book, but I never left. Friday, how many people? 2, 4, 6, 10, 14, 18, 22, 24, 25. 25 31ths of you are here. The power rule. Integer, then. Okay, so here's the power rule. If n is a positive integer, then d by dx of x to the n is equal to. Go ahead. Your turn.
X to the n minus 1.
Yeah, so n times x to the n minus 1, right? So x to the 4th, 4x cubed. Proof of the power rule. proved problem. This is what we're going to do, right? We're going to do d by dx of x to the n. Well, that's the limit as h approaches 0. Of f of x plus h minus f of x over h, right? And f of x plus h is, so it's x plus h to the n, right? And we just did it with 4, right? Minus x to the n over h. So now we're just doing it in general. So we're going to use, binomial theorem to say, well, okay, this expanded is x to the n plus n choose 1. Do you guys use that notation? Yeah? Okay. All right. You got that as well, right? But,
Yeah.
okay, I'm using that. Smack. Okay, that's what you've seen that though, right? Yeah. Okay, because we do it in 30-2, so everyone must do it in 30-1. Okay, so and if not, here's the notation. So that's n choose 1, x to the n minus 1, h to the 1, right? Plus n choose 2, x to the n minus 2, h squared, plus dot dot dot. H, or if you like, n choose n, h to the n. Okay, that's the end of that expansion. Minus x to the n, which is this, all over h. Okay, so we just did a specific, we just did a specific case of this, right? We just did x to the 4th, expanded it all out. This is the general case. This is x to the n. So what happened? Well, the x to the n and the cancels out with the negative x to the n, right? So those are gone. Cross them off. Extend the page. Slide back up. Divide out the h, right? Each term now has an h in it, right? So every term has, or you can think of like factor out the h and then get rid of them, or just divide h into every term that's there. So that'll be x to the n minus 1, that h is gone, plus n choose 2, x to the n minus 2, h, n choose n, h to the n minus 1. Okay, oh, wait, forgot the n choose 1. So all we've done is taken the line above, we've divided each term by h. Okay, no more h on the bottom. Get the h out of there. Now, as h approaches 0, what happens to each of the terms? So this term no longer has an h, right? But each of these do. So as h approaches 0, what happens to all of these? Gone. So we got n choose 1, x to the n minus 1. What's n choose 1? N. And there we go. Power rule approved. Okay. So d by dx of x to the n is equal to n x to the n minus 1. Now, that's a proof where n is greater than or equal to 1, right? So then the question becomes, well, so does that rule still hold? Like, what if n is a fraction? Will this rule still hold? What if n is negative? Will this rule still hold? So I'll give you a moment to ponder that. Finish writing down. We'll do another proof. This time we'll do it with root x. Okay, so we do the same deal. We're just going to do it with root x. And we kind of did one like this yesterday, right? So you look back at, what we do now, what we did yesterday. Oh, yeah, we did kind of the same thing, right? So what is d by dx? What do you think it is? Anybody got any idea? You don't say. No, I know you know. People who don't know, what do you think the derivative of root x would be? Yeah. Okay. Let's prove it. So we'll prove it, and then we'll say, well, so why is that, right? So it's limit h 0, so f of x plus h minus f of x over h, right? And f of x this time is root x, so it's root of x plus h minus root x over h. Okay, well, what do we do? Well, there's no binomial expansion or anything, right? What's the only thing we can do with this? Rationalize the numerator, right? Somehow we got to get an h up top to get the h out of there. So let's just take this as it sits and go root x plus h plus root x over. Okay, so we're good at this by now, right? Or by Monday, hopefully, when we have to do this for real. Count. So it's just this squared, right? So it's just x plus h minus this squared. That's all you do. You don't need to do fancy stuff. So we've set it up as a difference of squares. We square this, subtract. And then we got an h times root x plus h plus root x. And then here's where all the magic happens, right? What happens to the x's? They cancel each other out. So we got an h, and we got an h. So the h's. Now, right, we're at the point where it's okay, you put h in now because you want to end up dividing by 0. So what happens when we put h limit? So now we drop the limit, right? This is the point at which you stop writing this because you're now going to put h as 0. And we get 1 over root x plus root x, which is 1 over, well, we got 2 root x, which is exactly what you said, right? 1 over 2 root x. Okay, so come on. How'd you figure that out? What's root x if you express it in exponential form? 1/2. What's power rule say that you do? So you want to take derivative of that, so nx to the n minus 1. 1/2 x to the negative 1/2. What's a negative half do? Goes down to the bottom, becomes a positive 1/2. What's x to the half? That's supposed to be a 2 to the half. Yeah, so it's 1 over 2 root x. So this power rule apparently holds for at least for a half, right? I mean, we could do every other possible fraction, okay, or a more general. We're not going to get into more general proofs, but okay. So what's that say? That's consistent with. Okay, so that's consistent with d by dx of x to the n is n x to the n minus 1. That seems to work if it's a fraction. Also works if it's negative. Also works if it's a negative fraction. So let's do a few examples, like 4. Examples. Okay, if if f of x is x to the 6th, then f prime of x is 6x to the 5th. Much easier, right, than the limiters are in expanding x to the 6th. Right? You don't do that anymore, unless we ask you to show by first principles. That, if y is x to the 1,000, what's y prime? 1,000x to the 999. If y is equal to t to the power of 4, then what's dy by dt? Or t cubed. Yes, I'm suddenly working in all these different ways of f of x, f prime of x, y prime, y is t to the 4th, and then dy by dt. And how about d by dr of r cubed is 3r squared. Just, yeah, these better match, right? Can't do d by dx of r cubed. What then? What's this?
Negative x. Negative 2.
Negative x to negative 2. What's another way to say that? Negative 1 over x squared, right? So how'd you get that? Really, what are you doing? You're doing, how do you state this as an exponent or an exponential? Yeah, so it's d by dx of x to the negative 1. Okay, what do you do? Well, negative 1, x, so this comes in front, this goes down by 1. Okay. So you're just looking, you gotta say, hey, oh, gotta do that as an exponent, right? I'm not looking at it as 1 over x, I'm not looking at it as root x. We did that. So, we did it for an integer, but the general version of the power rule is if n is any real number, so the power rule holds for any real number, right? I mean, we looked at it with x to the 4th. We proved it for any integer. You can't use a binomial expansion for x to the negative 2/3. That doesn't work. That's the general version. Yeah, we got room to do a couple down here. Differentiate. Okay, f of x is 1 over x squared. What's f prime of x? Yeah, or ultimately. So we might go there in a couple of steps, right? I mean, we're going to say, so f prime of x is d by dx of x to the negative 2, right? So instead of writing it as 1 over x squared, we need to write it as x to the n, right? So we write it as x to the negative 2. And then we say, okay, so that's negative 2x to the negative 2 minus 1, which is negative 2x to the negative 3, which is negative 2 over x cubed. Okay, so give this one a try. Y equals the cube root of x squared. Okay, so you got to change it to exponential form, right? It's in the form x to the n. Okay, and maybe we leave it like that, and maybe we go like that. Either form, right? So you got to sort of get used to when you do a question, say multiple choice question, you get an answer, and it's, I got this, but I don't see any negative exponents, or I got this because I went all the way to here. Oh, and that's what I see as the answers, right? And so now that just sort of means looking ahead, right? Like what form are the answers in for these multiple choice questions? So where do I want to stop? It stopped with an exponent. They didn't actually go to a root. Okay, let me just stop when I get the exponent. Here, so let's do something. We got it? More or less. Yeah, that's good. Find the equation of the tangent line to the curve y equals x root x at the point 1, 1. Nice to you. I gave you the point, didn't make you substitute a 1 in for x and figure out that y was 1. Might have taken, if that. All right, I'm going to pause this. We're working on this, so the derivative So what do we want to find? The derivative of f of x, which is x root x, which is x times x to the half, which is x to the 3 halves, right? Because we've got to get in the form x to the n, which we have now, 3 halves, is f prime of x is equal to 3 halves x to the... Now, do you want to see me write 3 halves minus 1, or can I just do 3 halves minus 1 and get 1 half? Okay, that's fine. Thanks. Just looking for permission. So you can do that, right? You just, you know, you can in your head or on your calculator, which you can't use. So in your head, right, you have to start doing fractions, right? So you're going to have to go 3 halves minus 1 half is, or on a piece of scrap paper somewhere, you're writing 3 halves minus 1 half, which is 3 over 2 root x. Okay, that's my slope. I've got the point, right, which was 1, 1.
That's not right.
What? Oh, right. Sorry. 3 halves root x. Good. See, that's why you guys are there. correctly. So we have a decent set of videos with no mistakes in them. Right? That's your purpose. You can look back years from now. You can say, hey, I was part of making sure that I didn't screw up all the videos. So we say, so the slope of the tangent line at 1, 1 is f prime of 1, right? When we want the slope of the tangent line at that point, right? It's not a straight line, x root x. Is f prime at 1, which is equal to 3/2. Therefore, the equation of the tangent line is y minus y1, which is 1. I like formulas, I'll write it out. So y minus 1 is equal to 3/2, bracket x minus x1. And they gave us the point 1, 1. Which is...
How come you don't...
there. 3/2 x minus 1/2. So what does that look like? Oh, so let's see. I should be able to graph 3/2 x minus 1/2. And y equals x squirt x. So that's the point, right? It should be the point. So does that look like a tangent line? Looks pretty much like a tangent line at the point 1, 1 to the curve y equals x root x is this line. Okay, here is the constant multiple rule. Last one. Okay, so if c is a constant and f is a differentiable function, then d by dx of c f of x, so if we have some constant times a function, is simply equal to c times the derivative of the function. Okay, in other words, you can pull the constant out and just do the derivative. Proof is on page 80, 81 of your textbook, right? So, I mean, so I'm not going to prove it. I'll just do it. So we'll just do a few examples of it, and that'll be that. So it looks like this. If you have d by dx of 3x to the 4th, then you say, well, I'm going to pull the constant out front, right? So it's going to be 3 times and we know how to do the derivative of x to the 4th, right? So it's 3 times 4x cubed which is 12x cubed. Let's call that A. B. D by dx of negative x is, okay, negative x means negative 1 is a constant, so it's negative x. What's the derivative of x? That'll be 1 times x to the 0, right? There's a 1 on there, the invisible 1. So it's 1 times x to the 0, which is 1 times 1, which is 1. And you just get negative. And one more, and then we'll be done. Sorry, let's do d by dx. Of 5x to the 3/5. Okay, so that's 5 times. So it's 5 times. What's the derivative of this? Three-fifths x to the negative 2/5. And 5 times 3/5 is 3. You know what? I just leave it like that. There's some point where it just isn't worth writing fifth root of x squared on the bottom thing, right? Like it's just better to just leave it like that. So actually, really, when you use this, you don't, this is why it's going on. But you just look at this and go 4 times 3x, so you go 12x cubed, right? Like 4 times 3x squared. Or sorry, 3x cubed. So you move the 4 out. The 4 just comes in, multiplies the 3, and that drops. Right? Then negative, the 1 comes, multiplies this. Right? In effect, that's what you do. This is really what's going on, but in effect, you're doing it.
And like you could still write that as like 3 over x.
Yeah, it'd be 3 over, yeah. They're all the same. Okay. So really, it's looking at, oh god, they've stuck a root on the bottom of that. So when I'm looking for my form of the answer and I'm getting the negative 2/5, I know that I need to get it written as a radical on the bottom because that's the form that the answers are in, and so that's where I'm going. But practically speaking, I think you're, like if it's just an x to the half or negative a half, that's fine. Like throw root x on the bottom, that's okay. But and also, you need to also look, where am I going with this, right? Is this just part of something? So I really don't want to be writing this because it's really going to be helpful if I have, like, what if I take the derivative of this? Well, you don't want to do it from this because you'll have to back this all the way up to here to do the derivative of this. What happens if you take the derivative of the derivative? Well, the second derivative. What happens if you take the derivative of the derivative of the derivative? And so on. Right? How long? You keep going.
Really good.
The third, the fourth, the fifth. I'll take the fifth.